Okay, here we have a question about nucleus decaying, and we want to know about which series of emissions will produce an isotope of X. Okay, we've got a bunch of combinations there. Again, there's a lot of opportunities here for us to do some ruling out. Let's try our multiple choice strategy on this one. Okay, so I think that a good thing to remind yourselves is what an isotope is. This is the key to answering this question. We're going to make sure that what we've got is the same Z but different A. We don't really need to worry about A, so we're talking about proton and nucleon number here. We don't really need to worry about the A, we really need to focus on the Z here. Okay. Now, what we need to remind ourselves of is what happens in each of these processes. For alpha, we're going to have a reduction in our Z by 2. So we've got a reduction there of 2. We need to find a way, if we have any kind of alpha decay, we're going to look at first reducing Z by 2. So if I had alpha decay, so I'm really homing in on A and B here, just one decay initially, we have to think of ourselves, well, how could we then bring that Z back up? You've got at the top here, beta plus and beta minus. Well, beta minus has got this symbol here, 0 minus 1. And so it leaves our daughter nucleus as having an increased Z, which is increased by 1. So can you see here that if we were to have A, this would reduce Z by 2 and then increase it by 1, 2 to make 0 again. If we were to then look at, so this is why A is the answer. Now, if we just go through the other answers to just check to make sure that these kind of aren't the answer, alpha reduces Z by 2, then this beta plus reduces it by 2 more, so we're going to have minus 4. This alpha reduces 2 alphas, 2 times 2, take away 4, and then adding 2 here, we've got a net change of minus 2. And this one's huge, we're going to lose 4 and 2 more, which makes 6. So in this case, this is the only combination which returns us to 0, and that's why we produce an isotope of X.